Okay, so here we have a starting system wiring diagram for a 2000 Honda Accord with the 3-liter engine. And today we're going to be going over the basics of the starting system, and as you can see, it all begins with the ignition switch. When the ignition switch is closed, power travels down to the starter cut relay, which causes the switch to open. When that happens, the power comes down to the starter relay switch, or starter relay, and it travels over and it provides power for your starter motor and closes the switch, and power goes over and grounds to the battery and runs into the fuse box as well. And as you can see, this fuse box is located under the hood on the right rear corner of the engine compartment. We also have a fuse relay box under the driver's dash side, and when you're doing this test, you have to make sure that the car is in the neutral position, that way it can start, otherwise no power can flow. And as you can see, the powertrain control module is located in the floor console of the vehicle. And the last fuse that we need to cover is under the driver's under dash fuse relay box behind the left side of the dash panel. Okay, so when working with the components of the starter system, you need to identify where all the components are. Over here we have two separate fuse boxes, which for this training video we won't need to mess with at all. So we're just going to ignore those. And as you can see down there is the starter. Even though it's kind of hard to see with it being dark, the starter is in fact down there. It's right there. And then we have the battery over here. Now we went ahead and already pulled this, which this is the starter relay for the car, so that this way, in order, we can still test the car and have power, but it won't turn over. And this is located way up under the driver's side of the dash, so we're not going to show you that, but you should be able to find that on your own. Okay, here we have a diagram of the neutral safety switch, which is located on the driver's side of the transaxle. And you want to make sure that when you're working with this, that you go ahead and disconnect it, so that just to make sure that you don't have any problems. And you also want to know where it's at, just to be safe. When you were doing the starter draw test and the volt drop test, you want to make sure that you pull out your ignition coil fuse. That way you can still turn the vehicle over and get a good reading, but that way it won't crank and start running, so that you don't have any issues. Okay, so today we're going to be doing a open volt test on the battery, and what the purpose of this is to see what the voltage is of the battery when nothing is turned on in the vehicle. There is no system on. Then you still want to see what the voltage is. So we're going to go ahead and take our DVOM, make sure your leads are connected in the right spot, and turn it to volts. Make sure that you adjust the range accordingly, and then go ahead and connect your leads and see what you get. We are getting about 8.9 volts of battery, which means our battery is a little bit low, and we should go ahead and place it on the charger. Okay, so as you can see here, we have our starter relay out of our vehicle that we pulled, and basically what we have here is a basic schematic of this relay. Here you can see in which way the terminals are laid out and how they plug into the connector, and basically how this starter works, where you have the switch closing, which pushes against the coil and creates your spark for your start. And here everything is labeled, and basically that's what you would find if you were to take apart this relay and open it. So the next thing we're going to do is we are going to go ahead and do what's known as a starter draw test, which is where you have a lead hooked up down to the starter and to the battery, and you use a machine which is designed for this. And basically what it does is, with the system, when you crank it, measures to see how many amps the starter draws. Go ahead and crank it. Alright, so as you can see, it averages about 103 amps. Here we have a list of cranking test specifications for our vehicle, and it shows that for our vehicle, for the Accord, the maximum amount of amps we should have is 380, and we had a average of 103, which means we are within specification and everything is working properly. Okay, so what we're going to do now is we're going to go ahead and test this positive battery cable, this big fat positive battery cable that runs from the battery to the starter, and we're going to see how much voltage drop is going across, if any. Okay, go ahead and crank it. Alright, and as you can see, we have it had about 0.3 volts, which means that there is a slight voltage drop. Maybe the cable is worn out over time. So now we are going to do a volt drop test against the negative battery cable, just like we did the positive, just to see how much resistance is in the cable. So go ahead and crank it, Barry.
This time we're going to stop this.
As you can see, we have about 0.4 volts of resistance. Okay, so the next thing we're going to do is, you can see, we went ahead and pulled the starter out of our vehicle. We're going to go ahead and do what's known as a bench test, which is the easiest way to test and make sure that the starter works. When you do this, go ahead and make sure that you hook up your jumper wires in the correct order. We have a battery underneath here. Remember, when you remove them, it's in the opposite order. And when you do this, you want to make sure that this alligator clip is hooked up to the positive of the battery jumper cable. And then when you do this, stick this in the S terminal of the starter, which should act as which should open the switch and allow the starter to be tested. And as you can see, the starter works.